Hello everyone, today I will be talking about derivatives, or more, the intro to derivatives. This will not be a class discussing the intuition behind the derivative or where it comes from. This is basically a class because you might have a test tomorrow or you might have a test a week from now and you want to do your as well as you can on the test. We will go over the rules of derivatives that you will need, and then we're going to solve as many different types of practice problems as we can to make sure you're prepared well for that test. Now remember, this class will not be going over the higher level derivatives like the ones that require the chain rule or the quotient rule or the product rule. Those have videos on their own. This is only on the intro part of derivatives. So let's go forward. First things first, let's go over notation. You might be given a notation like this. Now both these things, dy over dx and f bar of x, mean the same thing. They basically mean you're deriving a function of y where the dependent variable is x. Now, for the sake of ease, we're going to use this notation throughout these practice problems. Now, the rule of constants. A derivative of any constant is 0, regardless of what the constant. The constant can be negative, it can be positive, minus 1, 2, 3, 10, 100. It doesn't matter what the constant is, it's going to be 0. The power rule. This is very, very important. So basically, if you're given a function in the form of this, x to the power of n, the derivative of that is going to be n times x with the original power minus 1. This rule is very, very important because you will be solving most of your derivatives using this. Now you have linearity. Now derivatives follow linearity. Basically, if you're given something in the form of this, where you're given a function that's added to a constant or another function, you will basically solve those two things individually and then add them together based on whatever sign it was previously. For example, here, x to the power of n plus c, you basically just do the power rule. Basically do the power rule here, and then derive the constant, and then you add it together the way it was. And if you're multiplying a constant by a function, basically take that, keep that constant aside for a second, and just derive the function itself, and then multiply the derived form with the constant. Now let's solve a few practice problems. Now I encourage you to solve these problems on your own because learning only happens when you try and do things yourself. So long story short, if you're given something like this, x cubed, you'd remember the power rule, where you'd basically multiply the power by the x, and you'd minus 1 from the power. So here, the derivative would be f prime x equals to 3 times x, because 3 is the power, and then you minus 1 from the power. It is going to be x squared times 3. That's going to be the answer here. Let's say you're given this. Now you'd remember what we talked about linearity, and basically take the constant aside and you derive the function itself, which would be 2x to minus 1 from the power rule. And we would get 8 times 2x, which would be 16x. Now, this function might look a bit hard, but it really isn't. So, we would how would we do this? Well, we do it the same way we usually do. This is also a constant. It might not look like it, but it is also a constant. So we basically do the same rule. We keep the constant aside for a second, and then we do the power rule. 10x with 10 minus 1, which is 1 over 5 times 10x to the power of 9. And the final answer will be 2 times x to the power of 9, because 10 divided by 5 is 2. Here, now, you might stumble on this at one point. How do you do this? Well, this is where you have to remember that the square root of x can also be written as x to the power of 1 over 2. That makes it easier. Now you just follow the power rule here again. So x to the power of 1 over 2, you basically bring 1 over 2 to here, down, multiply that by x, and then minus 1 from 1 over 2, which would bring negative 1 over 2. You can write this as 1 over 2 to the power of x, 1 over 2, which will be 1 over 2 square root x. Now this looks like a pretty big function here. It really isn't. This one is basically, remember linearity. How would you do this? You basically solve all these individually, and then we add the final result at the end based on the signs that we were given. So first we do this one, which follows the power rule. 3x with 3 minus 1, which would be 2, 3x squared. Then we do this one, which would be, first we look at the sign. Then we do this one, which would be 8x, when we know that 8 is a constant, it's being multiplied by x, which is a function. Take the constant sign and then derive the function itself, which will be, the derivative of x is going to be 1. So we go 8. And then we see the sign, it's plus. And then the derivative of constant, 3 is a constant, will be 0. So all this plus 0. So the final answer will be 3x squared minus 8. Now, what if you're given something in the form of this, with brackets? Well, that looks pretty straightforward, doesn't it? You expand it and then solve it. We expand it, which would be x cubed plus 4x. And then we solve it the way we usually would, with the power rule. 3x squared, you see the sign, it's plus. And then we solve that, which is going to be 4. And then what about this? You'd be like, okay, how do we do this? This is, the power is not exactly on top. This looks weird. Well, remember, sometimes we have to write functions in a different way than they're given. Here we can write this as x to the power of minus 2. Now it makes it easier. Basically, you solve this the same way you would any other derivatives, with minus 2 as the power. We use the power rule now. And that would be minus 2 times x with minus 2 minus 1, which will be negative 2x minus 3. So negative 2 over x cubed. And that would be how it is. Just make sure that you keep track of the signs in questions like these, because that's what usually stumbles people. And that is how you would solve these questions. Now, remember, these are just a few types of questions that you could get. The most important thing is to remember these rules here. And then you can apply these rules to any problem in the integer derivatives. Now, next time we will learn about chain rule and power rule and everything, because that's a whole other topic in itself. Thank you, everyone. Goodbye.